So as I continue from last video, I'll now have, let's see, variable z equal to 1000. And now we're gonna have to have and we're gonna use the scipy function that we entered before. It's gonna be res.solve equals IVP minus vres p.solve. We're gonna have dh, which is the function that we defined earlier. We have h I1, h I2, it goes 0 to z, the method equal to do, and there's one more, it's going to be dense output, and I gotta remember what that is equal to. True, C, it's so, I believe it has to do something with syntax. Solve IVP. Just saying it's still more syntax. So that's right. This should do it. Assuming we're going to miss R, so we'll take that off for now. So after that, let's try something new. What should I set this equal to? Say plot to jmp dot when space, when it evenly spaced, 0 to z, let's say 1001. Since this method argument y, because I probably put this in when I don't, doesn't make sense right now. Solve equals res solve t plot I don't know why it's saying this is wrong. There's something to do with this up here. And I don't have the correct stuff. Yeah, I don't see anything wrong. Scrap is defined. As we continue, I'm gonna pause and I'm gonna add the graphs. So these are the graphs that we're gonna add. We do make subplots rows 1 and columns 2 because we're gonna have 2 columns, so it splits it. So 2 of the graphs are gonna be on the same two of the lines or functions are going to be on the same graph. But now that we do that, I realize we need to go back. So let's shift enter here. I want to move on. Let's move my pictures. Move you up. What the hell? Alright. So when we do that, we're going to need a sigmoid function actually now. So let's define some values of t, v1, two's volumes, t switch, scale. We're going to use a jax function now. So we're going to return jax p dot sigmoid. Yep. So t. This is going to give us what we need for the breaks that we're going to have to apply into this. So scale v1 minus v2. Do this. Define them. And now what we're going to return, so we're going to have this in the right order. So let's see if I do it right the first time. Q the initial times 0.8. I got 200, 101. That's just going to make it break on the graph. At that point, it's going to show like a very obvious break. So let's do the same thing here. I'm not sure this is how it exactly goes, but let's see. It's 2.5. This happens at 200. Okay, it seemed like it worked. And I realized two mistakes. One, I didn't put the switch in front of here. And two, I forgot to put the T in front of initial. Yeah. Okay. Let's see if all this works out now from the beginning. Hopefully it does. And it's still saying there's a float. And I realized again, this is not initial. We gotta use the original functions that we had at the top. You're gonna be Q1N. And you're gonna be Q1N. And you should be Q2N. And you should be Q2N. So shift enter, shift enter, shift enter. And Q2 and 1, 2 initial isn't defined. Yeah, because it isn't. It's Q1N. Thank the Lord today. And we get this, and it's this probably isn't right. So let me check what is wrong here. I believe I got all the errors out. I had that T divided by, and I switched it to minus, and I had a V1 minus V2, and I switched that to V2 minus V1. So let's start from the beginning. Shift enter. And these look about right. as far as I know. And if you're going to account for the change in radius, I have something that I made up in a different program, but essentially you have a circle, and the change of radius due to time is changing with height due to time. So essentially you're going to get the radius that's changing the time is going to be equal to the square root of 2 times the height at the radius, so radius of that circle, 1, that's not going to change, minus h squared. Now I'm just going to put that in here. Would be something like, that is what I wanted. Should be something like that. However, I don't believe you can do that since you can only define 2 functions at once within a parameter. But as you speak, like the radius here, you're going to the JMP square root of 2 times h1, it's r1. Since the radius of the circle actually isn't going to change, it's going to be the radius of the cross-sectional area that it's going to be doing changing. So that will actually be constant in each one. So you can get the new radius, because the height will change, and that will be the determining factor in what the new radius will be, and then you'll try to multiply to get the area. So get that out of there. These look about right. So yep, this is how you find the heights that change, the change in heights and change in flow rates in coding and collaboratory.